Good morning, children. In the last class, we discussed about the properties of rational numbers, such as closure property, commutative property, associative property, role of 0, role of 1, additive inverse, reciprocal, and distributive property. I hope all of you practiced it well at home. You know, children, for what we are using all these properties? We are using the properties for making the operations with rational numbers more easy. Here is a question to simplify using distributive property. The question is this: using distributive property, simplify 2 by 3 into negative 3 by 5 plus 2 by 3 into 7 by 10. How can we simplify this using distributive property? For that, you have to look how many terms are here. Here one term, here this is another term. You know, you studied addition and subtraction symbols separate the terms. So here this is a term, this is another term. Two terms are here. And in these two terms, we can find one common factor. In the first term, there is 2 by 3. In the second term also we can see 2 by 3. We can take the common factor outside. Here 2 by 3 is common, so that 2 by 3 we can take outside. 2 by 3 into, that is common. Then put a bracket. Then from this we took outside this 2 by 3. Then what is remaining here? Here it is remaining negative 3 by 5. So that negative 3 by 5 we can write. Then here the sign is plus. So that plus we wrote here. Then from this 2 by 3 we had already taken outside. Then what is remaining here? 7 by 10. So that 7 by 10 also here you have to write. Here we applied distributive property. Because in the last class you studied A into B plus A into C equal to A into B plus C. That means here A, in the next term also one A, that A we took outside, then remaining here B, here C. So A into B plus C. In that form, here also we made it. And we have to do the operations in the bracket first. 2 by 3 into. Here comes the addition of two rational numbers. You know it well how to do operation addition with these rational numbers. For that, we have to find the LCM of the denominators. Here the denominators are 5 and 10. So what is the LCM of 5 and 10? The LCM is 2 into 5, which is 10. So we have to make each denominator 10. So negative 3 by 5. We have to make the denominator as LCM. So already in the denominator it is 5. So here we have to multiply denominator with 2 in order to make it 10. So numerator also you have to multiply with the same number 2. Then plus. Here no need to multiply with any number because already denominator is 10. That is 2 by 3 into negative 3 into 2, negative 6 by 5 into 2, 10 plus 7 by 10. It is equal to 2 by 3 into, now denominators are same. So write the common denominator, then add the numerators. So that is negative 6 plus 7, which is equal to 2 by 3 into 1 by 10. That's equal to 2 by 30. by 30. Then the simplest form, you can divide both the numerator and denominator by 2. So we will get 1 by 50. So the answer is 1 by 50. Here we applied distributive property. For applying distributive property, you have to take the common factor outside. Then do the operations in the bracket. You will get the answer. Children, now we can do one another question to use properties of rational numbers. The question is this: 2 by 5 into negative 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 5. How many terms are here? Here 3 terms are here. That is 2 by 5 into negative 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 5. Can you find any common factors among them? We can find here 3 by 7. Here also we can find 3 by 7. Here negative 3 by 7. Here also we can make it as negative 3 by 7 because minus 3 by 7 is same as plus negative 3 by 7. So first of all we can do the first and the last term using associative property. So 2 by 5 into negative 3 by 7 minus 3 by 7 into 3 by 5. This we are grouping together. Then minus 1 by 14 outside using associative. Then here look, 2 by 5 into negative 3 by 7 minus 3 by 7 into 3 by 5. You can see minus 3 by 7. Here also you can see negative 3 by 7. So that negative 3 by 7 we can take outside. So what we will get inside? Here remains 2 by 5. From this minus 3 by 7 we took outside. Then what remains inside? Here remains plus. Because minus means plus minus. So minus 3 by 7 we took outside. So here remains plus 3 by 5 minus 1 by 40. Here you look which property we use here. Taking common factor outside means we use the property distributivity. Distributivity. Then we can simplify the terms inside the bracket. Here you can see the same denominator 5, then add the numerator minus 1 by 40. That's equal to minus 3 by 7 into 5 by 5 minus 1 by 40. That is negative 3 by 7 into 5 by 5 means 1 minus 1 by 40. That is negative 3 by 7 into 1. Negative 3 by 7 minus 1 by 40. Now we got here different denominators. So we have to find the LCM of the denominators. Here denominators are 7 and 14. So their LCM is 14. So we have to make each denominator 14. For that first term you have to multiply numerator and denominator by 2. And second term, no problem, the denominator itself 40. So negative 6 by 14 minus 1 by 14. So now we got the same denominator. So we can do operations with numerator. So common denominator 14. Then negative 6 minus 1 which is equal to negative 7 by 14. That's equal to negative 1 by 2. Simplest form is negative 1 by 2. Here we applied two properties. One is associativity and another is distributivity. And we used and simplified and we got the answer as negative 1 by 2. Children, our next topic is representation of rational numbers on number line. You know how to represent natural numbers and integers on number line. For example, in the middle you have to mark 0. On the right side positive numbers, and on the left of 0 we have to mark negative integers. Then in this class we can study how can we represent rational numbers on the number line. Children, now we can look how to represent rational numbers on number line. For that, mark 0 in the middle of the number line. On the right of 0 we can mark positive integers. On the left of 0 we can mark negative integers. Suppose we have to represent 1 by 2 in this number line. 1 by 2. Here in the denominator it is 2, and this rational number numerator is less than denominator. In such cases, the value is in between 0 and 1. That means 1 by 2 is a proper fraction. The value of a proper fraction is in between 0 and 1. So in 1 by 2, denominator is 2. So that much equal parts you have to mark in between this 0 and 1. So 2 equal parts. So in the middle you have to mark a point. And from this 0, you have to mark 1, first part. So from this 0, first part means the part this itself, and this point will be 1 by 2. Then one another question we can look. Suppose we have to mark 3 by 4 on the number line. So we can draw another number line. In the middle mark 0. Here plus 1, plus 2, etc. Here also the given rational number is proper. So you have to look at the denominator. The denominator it is 4. So we have to mark 4 equal parts. 1, 2, 3. So from here to here, first part, second part, third part, and last one, fourth part. And from this 0, first part is 1 by 4. Second part is 2 by 4. And third part is 3 by 4. And the fourth part is 4 by 4, which is equal to 1. And we need this part, this 3 by 4. So this marked point represents 3 by 4 on this number line. Similarly, one another question. Suppose we want to mark 5 by 8 on the number line. 5 by 8. So 0, 1, 2, like this you can represent 5 by 8. In order to represent 5 by 8 on the number line, you know children, here also this is a proper rational number. So the value is in between 0 and 1, and the denominator is 8. So we have to mark 8 equal parts in between 0 and 1. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts we needed, and each part is 1 by 8. Out of 8, this one is first part, so it is 1 by 8. The next one is 2 by 8, etc. Then fifth part, this is 3 by 8, 4 by 8, and this part will be 5 by 8, which is required here, 5 by 8. Then now we studied how to represent positive rational numbers on number line. Now we can look how can we represent negative rational numbers. For example, if we want to represent negative 3 by 4 on number line, so it will be on the left side of this 0. And clearly this is proper rational number. So the value is here, it will be in between 0 and negative 1. Then as usual, look at the denominator. It is 4. So we need 4 equal parts. 1, 2, 3. Now here 4 equal parts are there. Then we need to mark negative 3 by 4. First part is negative 1 by 4. Second part negative 2 by 4. And third part is negative 3 by 4. Then the fourth part is negative 4 by 4, which is equal to negative 1. In this way, we can mark negative rational numbers. Then next we can look how can we mark improper rational numbers on number line. Improper rational numbers. Suppose we have to represent 7 by 4. Here, numerator is greater than the denominator. Numerator is greater than the denominator. So, its value is greater than 1. So, if we are marking here plus 1, plus 2 here, the value of an improper fraction is greater than 1. So, we can divide it by 4. 7 by 4. We have to express 7 by 4 as a mixed rational number. So 1, the mixed fraction for this 7 by 4 is 1, 3 by 4. So the value is after 1, then 3 by 4 we need it. 1 is a whole number. So up to 1 we have to mark up to this. Then after that 3 by 4 we need it. So again we need 4 equal parts, 1 by 4, 2 by 4, 3 by 4, and the required rational number is this. The position of the required one, 7 by 4 is here, after 1 and in between 1 and 2, because when we change this improper rational number into mixed rational number, we got 1 and 3 by 4. So the value will be, or the position of this 7 by 4 will be in between 1 and 2, because the value is 1 and 3 by 4. Children, one more example we can consider to represent improper rational number. One rational number, that is 5 by 3. How can we represent this 5 by 3 on this number line? So for that we have to make it as mixed rational number, which is equal to 5 by 3 equal to 1, 2 by 3. Quotient, then remainder by divisor. 5 by 3 is same as 1 and 2 by 3. So clearly the point will be in between 1 and 2. So after 1, which part we have to mark? 2 by 3. After 1. So after 1, 2 by 3 means we need 3 equal parts, because in the proper fraction here denominator is 3. So we need to mark 3 equal parts. 1, 2, 3. 3 equal parts. Out of that 2 by 3. This is 1 by 3. This is 2 by 3. Which is the required point on the number line. 5 by 3. Children, now we learned how to represent rational numbers on number line. Our next topic is rational numbers between any two rational numbers. For that, take one example, 3 by 10 and 7 by 10. How many rational numbers we can find in between these two? You know, on the number line, we studied how to represent these odd numbers, 3 by 10 and 7 by 10. So, in between this 3 by 10 and 7 by 10, we will get 4 by 10, 5 by 10 and 6 by 10. Now we got 3 rational numbers by 10. Now look at here children. 3 by 10 is same as 3 into 10 by 10 into 10. If we are multiplying with the same number on both numerator and denominator, the value will not be changed. So it is equal to 30 by 100. Similarly, 7 by 10 is equal to 70 by 100. Instead of finding rational numbers between 3 by 10 and 7 by 10, we can find rational numbers between 30 by 100 and 70 by 100. In between 30 by 100 and 70 by 100, we can find 31 by 100, 32 by 100, 33 by 100, etc. 69 by 100. So we got many rational numbers. Then once again we can multiply this 3 by 10 on both numerator and denominator by 100. We will get 300 by 1000 and 7 by 10 as 700 by 1000. Then also we can find many rational numbers between 3 by 100, no, 3 by 10 and 7 by 10. Since 3 by 10 and 7 by 10 is equal to 300 by 1000 and 700 by 1000. Again we can understand that 3 by 10 is same as 3000 by 10,000, 7 by 10 is same as 7,000 by 10,000. Then also we can find many rational numbers between them. From this we can understand that between any two rational numbers we can find infinitely many rational numbers. Our next example is find 5 rational numbers between 2 by 3 and 4 by 5. Our last question was 3 by 10 and 7 by 10, and we have to find the rational numbers between them. There the denominators were same, but here denominators are not same, 2 by 3 and 4 by 5. So first of all we have to make the denominator same. How can we make the denominator same? By finding the LCM. What is the LCM of 3 and 5? LCM is 3 into 5 is equal to 15. LCM is 15. So we have to make each denominator as 15. Here denominator is 3. In order to make it 15, we have to multiply it with 5. So numerator also you have to multiply with 5. This is equal to 10 by 15. Then 4 by 5. We have to make the denominator 15. For that we have to multiply 5 with 3. So numerator also you have to multiply with 3. So it is equal to 12 by 15. So now we got 10 by 15 and 12 by 15. In between this 10 by 15 and 12 by 15, we can find only now 11 by 15. But here we have to find 5 rational numbers. For that, what we have to do? 2 by 3 we got as 10 by 15 and 4 by 5 we got as 12 by 15. So we have to get 5 rational numbers. We got only now 1 rational number. So again we can make a denominator same by multiplying with 10. So what we will get? 100 by 150. Here we will get 120 by 150. So instead of finding rational numbers between 2 by 3 and 4 by 5, we can find rational numbers between 100 by 150 and 120 by 150. 100 by 150 and 120 by 150. So which are the rational numbers between this? 101, 101 by 150, 102 by 150, etc. We can find the rational numbers. So children, in order to find the rational numbers between any two rational numbers, first of all we have to make the denominator same by finding the LCM. Then also if you are not getting enough number of rational numbers, we have to make the denominator as multiples of 10. Then you can find as many rational numbers in between any two rational numbers. Then one another question. Suppose you have to find only one rational number between two rational numbers. You have to find only one rational number between two rational numbers. For example, 1 is a rational number. Since 1 can be written as 1 by 1 is a rational number. 2 is also a rational number. You know, in between 1 and 2, the number comes is 1 and half. It is clear. In between 1 and 2, the number comes 1 and half. And 1 and half is same as 3 by 2. This mixed fraction we changed into improper fraction 3 by 2. How we got this 3 by 2? This 3 by 2 is 1 plus 2 by 2. This one is 2 and whole by 2, which is equal to 3 by 2. That means for finding one rational number between any two rational numbers, we have to take the average of that two rational numbers. I hope all of you know what is average, how we are finding average. Average we are getting by adding the two numbers and divide by 2. So for finding one rational number between any two rational numbers, we have to add that two rational numbers all divided by 2. Then we will get one rational number between the given two rational numbers. Suppose A and B are two rational numbers and we have to find a rational number between this A and B. We have to add A and B then whole by 2. This is the method to find a rational number between any two rational numbers. Children, in this class we have discussed about properties again and solved problems using properties. And also we studied how to represent rational numbers on number line and how to find rational numbers between any two rational numbers. After each class, we are giving the notes of that day. You have to copy it in your notebook, write it neatly and do practice. And if you feel any doubt in any question, you can call me directly. We can see you on next session. Thank you.